Lesson 50, solving multi-step equations. So first off, let's look at some steps that we want to use. So first we want to eliminate the parentheses or brackets by using the distributive property. That's only if you have parentheses or brackets. We want to combine the terms on each side of the equation. So like terms, that means they have the same variables and the same exponents on those variables. Then we want to move all terms with the variables to one side by using the opposite operations. So the opposite of subtraction is addition, and vice versa. The opposite of addition is subtraction. Multiplication and division are also opposites. Once you isolate the variable by itself, then you're going to use the golden rule of algebra, which is whatever you do on one side of the equal sign, you do on the other side as well. Let's take a look at an example here. Suppose a taxi charges $1.20 to start a ride plus $3 per mile. If a ride costs $5.40, how far was the ride? Let x represent the distance traveled in miles. So they already have the equation written for you. The 3x, because it's $3 per mile and x stands for the mile, and then you automatically have to pay the $1.20 to start the ride. And the total cost was $5.40. So to find out x, we're going to do the inverse operations. So I need to get 3x by itself. So right now I'm adding $1.20 to it. So the opposite of adding $1.20 is subtracting $1.20. But remember, whatever I do on one side, I have to do on the other side, because to keep the equations equal on both sides, I have to do the same thing. So now I just have 3x left over here because the $1.20 subtracts each other out. Then I have $5.40 minus the $1.20, which would give us $4.20. Now I can divide by 3 to get x by itself, because the opposite of multiplying by 3 is dividing by 3. 3 divided by 3 is 1x. Divide this side by 3. 3 goes into 4 one time. One times 3 is 3. 4 minus 3 is 1. Bring down the 2. You have 12, so 3 goes into 12 4 times. And so now I have plus I have to have my decimal point in there. So I would have gone 1.4 miles. If you were to show a longhand with the division, put the decimal point there. 3 goes into 4 one time, so 3 subtract, get 1, bring down the 2. 3 goes into 12 4 times, gives you 12. You have the 0. You can put the 0 at the end, you don't need to. But 1.4 miles would be the answer. Next one here, negative 2x minus 5 equals 9. We need to get the x by itself. So the opposite of subtracting 5 is adding 5. So now I have negative 2x equals 14. To get x completely by itself, I divide by negative 2 on both sides. X would have to equal a negative 7. You notice that every time our first step is always going to be adding or subtracting a number on both sides. Do not touch the number with the x until the last step. Next problem. 3x plus 5 equals 50. The opposite of adding 5 is subtracting 5, and I do that on both sides. So I have 3x equals 45. To get x completely by itself, we divide by 3 on both sides. X equals 15. And the last one here, 4x minus 12 equals 60. To get 4x by itself, I add 12 to both sides. I end up with 4x equaling 72. To get x completely by itself, divide by 4. 72 divided by 4 gives us an answer of 18. So those are a couple of examples of using really the golden rule of algebra, trying to get that variable by itself. But these are two-step processes. First, adding or subtracting. Last step, dividing. Let's take a look at a word problem. A computer repair shop charges $40 per hour. That's how they get the 40x here. Plus the cost of the parts, so plus 35. If the repair bill of $125 includes $35 in parts, then how long did the repair shop work on the computer? So this plus 35 is because it included the $35 in parts, and the whole thing costed $125. So now we need to solve for our variable. So the opposite of adding 35 is subtracting 35. So if I do that on both sides, I end up with 40x equaling 125 minus 35 gives us 90. To get x completely by itself, you divide by 40. That leaves us with 1x. Divide by 40 here. 90 divided by 40 gives us how many hours? This would be 2 hours, 2.25 hours, or 2.25 hours. So if you don't put it as hours, then you would just put it, a quarter hour is just 15 minutes, so 2 hours and 15 minutes. So I'll put that down, 2 hours, 15 minutes. Either way, you can have as your answer. And this next one here. Here you can see we have two x's on one side. So we need to combine those first. So 7x minus 1x is 6x. Then we have our minus 12 equals 24. Just remember when we add like terms, always use the sign that's in front of each term. So now, to get 6x by itself, I add 12 to both sides. I end up with 6x equaling 36. To get x completely by itself, divide by 6 on both sides. X equals 6. And final slide, here we have some more problems, combining like terms first. So here, 3x minus 1x is 2x, plus 4 equals 28. To get 2x by itself, subtract 4 on both sides. 2x equaling 24. Divide by 2, x equals 12. Next one, 30n plus 22 equals 292. Subtract 22 on both sides. 30n equals 270. To get n by itself, divide by 30. N has to equal 9. Next one, we have a fraction in there. X divided by 5 plus 4 equals 13. Still do the same thing. We subtract 4 on both sides. So now we have x divided by 5 equals 9. But now the opposite of dividing by 5 is multiplying by 5. So I'm going to multiply by 5 on both sides. So now 5 divided by 5 is just x. Whatever I do on one side, I must do on the other side. So multiply 9 times 5, and I get 45. The last three problems. Negative 2x plus 17 equals 3. So I'm going to subtract 17x on both sides. I get negative 2x equals a negative 14. The x by itself, divide by negative 2. And remember, when we divide negative by a negative, our answer is positive, so we get a positive 7. 3m minus 1.5 equals 4.2. Here I add 1.5 to both sides. I end up with 3m equaling 5.7. Divide by 3 on both sides. M would have to equal 5.7 divided by 3 gives us 1.9. And the final problem, 4x plus 10 plus x equals 100. 4x plus 1x is 5x. Plus 10 equals 100. Get 5x by itself, I subtract 10 on both sides. 5x equals 90. To get x completely by itself, divide by 5. X would have to equal 18. So that is our lesson today on solving multi-step equations.